depends on the parameter alpha. It represents the number of communications, the number of the computing nodes taking part in the communication. Okay. So this is the theoretical optimization analysis of the result, latency per message, transfer time inside one supernode. Okay. Then we do some optimization on parallel I/O. We split data into different blocks and store them on different disks so that we can use the aggregate bandwidth of multiple disks. Okay, then I'll show you some experimental setting and the results. We use customized Jinlei C compiler and the redesigned Jinlei MPI implementation. We compare our result with the Intel 12-core processor and NVIDIA K series GPU card. Okay, this is the result about the convolutional layer with explicit and implicit GM on one CG. It can see the forward time no matter when the convolution is 1-to-1, explicit is good, 1-to-2, according to different parameters. Implicit is good. For weighted diff backward, also according to the size of the convolution operations, we should use different GM optimization. Okay. So this is the comparison of GPU and and the Jinlei processor in the forward propagation of AlexNet and backward propagation of AlexNet. The difference we can achieve comparable performance. The performance difference comes from memory bandwidth. For GPU, it is of a high bandwidth of 288 gigabytes. Jinlei only has a bandwidth of 136. Then the performance difference comes from the transform layer, image to column and column to image operations. Okay. We also measure the scalability and compare the performance with Cafe on K series GPU. Yeah. Usually, the newly designed framework runs 3 to about 8 times faster compared with 24-core CPU on all the networks as shown here. Also, okay. Also, the newly designed framework can achieve a good scalability. This is the improvement on Empire or reduced with a reduced newly designed or reduced implementation. We can achieve over 4 times speed up. When with the number of CPU processors increasing, the performance achieved also increase linearly. Okay. Okay. That's the work. Now the concluding remarks. Through this work, we show that to get high performance of the underlying supercomputers, we should know the architecture and use the architecture specific optimization to get the best performance. In this sense, Shenwei Cafe achieves its goal. It is a high efficient redesigned parallel DNA training framework. We can get good speed up about the computation. Our experience about the optimization is that just as I told you in the beginning of this presentation, to get performance, it is necessary to know your hardware, the features the hardware could supply, and know your application. You should master the operations, the characteristics of your optimization so that you can bridge the gap in between by a lot of optimizations, by a lot of improvements. Okay, that's all. Thank you for your attention.
Thank you, sir. Thank you for giving your valuable time. Any questions, students? Any questions from students? Okay. Thank you, sir. Yes, sir.
Yeah. If you have any question, you can also drop me an email. Right here. Yeah.
Yes. Thank you, sir. Thank you, sir, for sharing your knowledge. Thank you all the participants for listening carefully. And I thank the management of ITM BU for giving us this opportunity. Thank you all.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you all participants.